So the composition theorem says that if the original, if my protocol row, okay, I have, sorry, if my principal, I have a mismatch of notations here. Yeah, and also mismatch of colors. I'm sorry about that. But okay, so what I want to say is that if my protocol, let me fix it. It's too confusing. If my protocol pi, this is supposed to be pi. Yeah, I'm sorry about that. I changed notation in the middle, and this is supposed to be f phi and forget the colors for a second. So yes, maximum confusion. I'm sorry. Yes. So exactly. So if my protocol pi, a single instance, realized my specification, my ideal service phi, the way we defined before. Now it's going to hold that for any protocol row, no matter what protocol row it is, all right, I take the protocol row that started with the phis, right, those phis, as subroutines, as services, right, and I replace each one of those with a pi the way I described before with the composition operation. Then I get a protocol like this, which actually realizes the original one, right? So it's like this can be thought of as the specification for this protocol. But even more generally, if this protocol realizes some other ideal service, then this one also will realize this other ideal service. Okay? So this is so that's the theorem. If protocol pi realizes a ideal service phi, and protocol rho realizes a ideal service gamma, okay, then the protocol rho, when phi is replaced by pi, also realizes gamma. And that's the statement, okay?
Example again?
Yeah. Okay, example. Okay, let's do an example. It's a good idea. Example. Let's do what we were doing before with encryption and authentication. Okay. Okay. So I have the protocol which is the MAC protocol, right? So where the parties have keys, right? And that's they're doing the MAC, right? So they get an M, A, B. And they remember the MAC protocol. Yeah. Okay. Yeah. Okay. So just to remind you the protocol, right? So that's the MAC protocol. And this protocol realized the ideal authentication functionality, right? Right. So there's the fauth, they got MAB, and also outputs MAB. There's also a simulated interface here, but never mind. Okay, so we have this protocol. This is what we have, right? And now let's talk about an encryption protocol that tries to realize the ideal secure message transmission service, which you remember, right? There was F secure message transmission. If you remember, it got an M here, A, B, right? And it outputs an M, A, B. But now the simulator, instead here you got M, here it got just the length of M, right? And we can realize this functionality by, again, we have these two parties that have keys, okay? And we want to actually do our life. Sorry? Oh, yeah. So I wanted to make our life easy, and I want to kind of assume that I have authenticated communication, right? So what I'm going to do, I get here an MAB, and what I'm going to do, I'm going to encrypt, use some semantically secure semantic encryption, MC, right? And then I'm going to give to here I have fauth. I'm giving here CAB, and fauth is giving me back CAB, and then I should decrypt, and then I'm going to output MAP. Right? So I'm just doing decryption with semantically secure encryption over fauth. Fauth, which is that. Okay? So now I want to compose them together. So the way I compose them together, I take this protocol, which is takes MAB, and that's the encryption protocol, and outputs C, which is enc of M, right? And then this thing before was given to fauth, but now I'm actually replacing this with the protocol. So now I have another key here. This is K1 and this is K2, and now what I get here, the result is C, A, B, and tag, which is the MAC on with K2 on A, B, C, and this is what I'm going to send over the network. And then the receiving end, I'm going to verify the MAC and then decrypt. Okay, so this part came from, this is the authentication part, and this is the encryption part, and I compose them together. And because of the composition theorem, I can deduce that this combined protocol actually realizes secure message transmission over an unauthenticated network.